Okay, and I hope that you see my screen well enough and we can make a start for this webinar. So, hello everybody. Welcome to the OneClick LCA Construction LCA training provided by OneClick LCA under the Saint-Gobain Architecture Student Contest. So this is the second session we are organizing and also the last one. So we had one on Monday and now this on Thursday. So some rules to begin with, the same as before. So please keep your microphones muted. I'm not sure if you're even allowed to open them, but anyway, if you have the option, don't take it. You can ask the questions using the Zoom Q&A function. So there is also a chat, but it would be better if you post your questions on the Q&A section so we can address them live during the Q&A parts of each session. So today we will have one at the end, but there's also a couple of my colleagues online that may answer your questions during the session. So this depends on the amount of questions, of course. So the recordings and slides are, of course, made available the next working day on Academy page. So you go to academy.oneclicklca.com to find them. They will be also posted on Saint-Gobain YouTube channel. So that is another place where you can find them. Also, I remind you to join the community. So in this community, you can ask questions, share knowledge, help your fellow students, check also the announcements. Also, like I said on Monday, if you have some specific questions related to LCA or the software, you can post them in the questions section, and I or someone else will be checking every now and then to try and help out. But I would also suggest to go to the help center. There's all the information you need basically is there. And yeah, so, but this is, one option that you can also use. We won't be there all the time, but we will be checking it out every now and then. So maybe once a week or so. Yes. So on Monday, sorry, I keep saying yesterday, but this was on Monday. So we talked about we had the introduction to building LCA and software training. So we had that introduction to OneClick LCA, the software and the company, and then we talked a little bit about climate change and construction. Also went through what is LCA, what are the life cycle stages for construction, life cycle assessment, and also the part about EPDs, so these environmental product declarations, what they are, how they're made, and how we can use the data in them. And also we gave a brief overview on important legislation and standards. And then we also showed you how to create your account, access the software. I will be giving you a short recap on that today. So if you don't remember how to do it or you didn't get to do it or you had problems doing it, so we can go through it today. Also, if you had issues with it, you can also post those in the Q&A section so we can check out if we can help you. And then we had the demo of the software. So we had that Excel import, and then just to check out through the different query tabs, so the materials and energy and also the results. But today is the second session, so we will discuss how to perform a building LCA at a very early stage. So this is a bit different from making an LCA where you know all your materials and know what kind of producers you will be using and so on. But in early stage, you might have very rudimentary information on how the building is going to shape up to be like. And as architects, you are focused on how to influence your projects and what kind of decisions you can make at early stage to reduce the impacts of your project. So we will talk about reducing emissions in practical projects, some golden rules to bear in mind. We will also have a demo of our early stage design tool, Carbon Designer 3D. And I will show you how to optimize the baseline results you get with it. And also we are going to go through interpreting the results and also some other aspects related to this. And in the end, like I said, we will have a question and answer session. So I am taking you to the first part now. So we are talking about reducing emissions in practical projects. So the term embodied carbon is popping up more and more, but what it actually entails might be a bit hazy. So just as a reminder, when we talk about embodied carbon, we mean the carbon or the characterized greenhouse gas emissions logged in the materials and the impacts then originate from the materials production and manufacturing, the material transport, the use and replacement of the materials, and also the end of life impacts of those materials. So it is a separate entity from operational carbon or operational impacts that are related to the energy and water used in the building. So here we will now discuss some of the most effective approaches from our 10 easy to follow design rules or commandments. We created an example baseline building design to quantify the potential impacts of adopting the different embodied carbon mitigation strategies. So I've added the link here if you wish to check it out from the original document. Based on this baseline building, we will see if we check all these principles, how we can reduce the embodied carbon emissions. So our baseline building is 7,000 square meter office building. It has 7 above ground floors of 1,000 square meters each, 2 underground parking levels and a precast concrete frame and a 60-year assessment period, assuming that the building would be kept in a condition for pleasing the third parties. So before we actually go in to see the strategies, I would like to remind you that when you begin working on embodied carbon, you should always make sure that your building has a decent energy performance and whatever low carbon energy supply options your locality can afford or offer. So even though we are talking about embodied carbon, we do know that operational carbon is very much there still, and it's not going anywhere, at least anytime soon. So you need to consider these as well. And also something that probably is a difficult thing to achieve as an architect. So avoid sites where transport relies on private cars and long transport distances for users. But it's something that if it can be relocated, it is worth to think about the options. So we can avoid private cars as much as possible and rely on public transportation. This is, of course, outside the building LCA scope also, but it's something that in a holistic approach you would have to consider as well. So here is a figure with our 10 commandments for reducing the embodied carbon. So we'll go through these points one by one, and at the end come back to check this graph out to see what actually affects what. So you don't have to now try to see what is there, but there is 10 different things to look at, and then the reduction of carbon in tons of CO2 equivalent. So the first commandment, do not build for short term, is the most effective, basically. So optimizing the life cycle impacts for anything less than a 50-year span is basically not worthwhile. So the shorter the service life of a building, the more impacts you will get per year. So if we build for 100 years, we have, of course, 10 times less impacts than if we build for 10 years, because everything should then be replaced every 10 years. So the longer the building lasts, the more sustainable they are. And it's if the need for the building is not sustainable, for example, if there are ongoing demographic changes or zoning changes, so this may be addressed by designing either a building that is highly adaptable or with a modular transportable building that satisfies the demand for a shorter period of time. So for example, in Finland, we have a lot of these like daycare buildings, for example, that are built to be replaced, like so that they can be moved as they are to somewhere else. And because they are often built in areas that have a lot of construction and people are moving in, and they might be a need for a bigger building at some point, so the smaller temporary building can just be relocated to another part of the city, for example. So in this picture, you will see the effect of the service life. So here, if you have a long-lasting building or like a sustainable building, it will have this maintenance and material replacements here. But if the material, for example, will last, or the building will last only 40 years, you will have replacement after 40 years. And then you would have the manufacturing impacts and the transport impacts all over again. So this increases, of course, the impacts. And the potential carbon savings in our baseline building are up to 50%. So compared to a situation where the service life is limited to 25 years, so the annualized materials-driven carbon impacts are, in this case, 120% higher. So, and if the building can be converted to another use, the impact is reduced even further. So after the service life, if you can use it for something else, that's even better. The second commandment is to avoid sites requiring soil stabilization. So deep foundations can usually mean quite high emissions because they require a lot of materials, and this material is usually cement, concrete, and steel. So these are all very carbon intensive materials. And of course, I recognize that architects don't really have the means to affect this site selection. But if you have the ability to influence the way the building masses are divided on the site, that makes a big change. So what you should consider maybe is the distance to bedrock, and think about the ways to mass the building so that the biggest masses are in place where the distance to bedrock is the smallest. And also it's worthwhile to think about the overall mass so that it would require, so that the required material for the foundations would be reduced as much as possible. But if you are committed to the site and you cannot avoid these foundations, so you should think about the mass, the bedrock, and like the lighter frames would be, for example, timber or steel, if you want to consider those. And finally, you should avoid cast-in-place concrete, which tends to result in the heaviest of all structural solutions. So here, the potential carbon savings in the baseline building are 30%. So if you also consider the replacements during life cycle, which is of course not needed for foundations, but in the whole building life cycle assessment, the foundation's share of the embodied carbon impacts is 40%. So this is even higher. And then the third commandment, consider structural options. So could a lighter or a timber frame work? So in general, the structural frame is responsible for the majority of the impacts, and it should be thus addressed prioritarily. So reducing the mass of the frame reduces the need for foundations and, of course, the overall material need. So wood, for example, is a relevant material to consider. So materials are inherently less carbon intensive, so they require less energy to be produced. So for concrete, you would, for example, need the excavation of minerals, the crushing and processing of those minerals, and a huge amount of energy for calcination and so on. But for wood, you need energy to harvest, transport, and sawmills often require little external energy because they can use residues such as bark and sawdust to create heat for drying and other processing. So wood is also natural, renewable material. So if you harvest from sustainable forestry, new trees will of course replace the ones you remove. And it's a natural carbon storage. So about half of the mass is carbon that is removed from the atmosphere and stored as long as the wood is in use. And at the end of life, the wood is usually burned. So the energy released replaces energy from other sources, which nowadays is mostly still fossil. And wood also has good strength to mass properties, good thermal properties, and is rather cost effective. So choose wood if you can. So in this graph, we have a comparison for wood and concrete frame. And with wood, we can achieve 10 to 20% difference in embodied carbon. So this is, of course, considering that the structural performance is the same. And also it should be noted that smaller scale changes, such as insulation, cladding, and other building parts can also reduce the impacts because the small savings pile up and can result in the end in significant reduction. Yeah, so the potential carbon savings in the baseline building are again 30%. And then commandment 4. So choose low carbon products. And this should be done by setting clear requirements and selecting the right suppliers. So the requirements could specify, for example, minimum carbon performance targets or other measures, such as stipulating the use of recycled binders for concrete, for example. And this strategy works effectively for all materials where supply is competitive, and some suppliers are willing to supply products with improved environmental performance. And comparing these products is becoming easier and easier as producers are producing more and more EPDs, which are, as we talked, very reliable documents on the environmental performance of a material. So, for example, here we are looking at different rebar products for steel reinforcement in concrete. So the difference between the best performing and the worst performing is around 70%. So manufacturers can reduce the environmental impacts by improving their process efficiency and choosing renewable energy sources as well. And for concrete, for example, these yellow bars here, when you reduce the amount of clinker by replacing it with other substances, you can reduce the environmental impacts. So concrete is made from cement and additives, and the process for producing cement is highly carbon intensive, so it requires high temperatures to produce clinker from limestone and clay minerals. So if we can replace that clinker with byproducts such as fly ash or slag from iron smelting, the carbon intensity reduces. And in this graph, we can see how the addition of GGBS, which is the abbreviation for ground granulated blast furnace slag. So this kind of stuff that comes from iron production. And then we also have addition of fly ash. And they reduce the global warming potential of concrete compared to very basic concrete with no additional binders or recycled components. And the strength, of course, here stays the same. So it's always important that you know what you're comparing so that they have the same performance. And on blue, we see brick emissions. So this is a common clay bricks with a higher column, and then reclaimed brick with a very small impact. So bricks are actually quite easy to recycle. They need some processing, cleaning, but otherwise they are reusable for a very long time. And then in green, we see steel rebar. So there's an average EU value on as the high column, and then a smaller column for this 100% recycled content. So again, steel is of course quite easy to recycle. So it's a much more energy efficient process. And then choose low carbon products. So potential carbon savings in the baseline building is around 10% in this case. Commandment 5 is to optimize the building shape so you can achieve a mass reduction with a compact shape. So as a general rule, a simple shape is more materials and energy efficient. So the smaller the material quantity, the more efficient building you have, of course. So more complex shape drives these external wall demands, for example, and also requires additional access corridors. And what should be noted, of course, is that the building, like the elevator shafts, for example, are needed in different locations if we have a bigger building or a different shape, and corresponding room area increases. And however, it's not always possible to create square buildings, but it does not change the fact that simple shapes with comparable function and materials mean lower impact. So this is something to consider, taking into account, of course, the zoning, functional, and space distribution requirements, for example. And the potential carbon savings in the baseline building is about 10% here. Commandment 6 is to design thinner floor slabs. So horizontal structures are responsible for a big part of the embodied carbon emissions. And unlike the envelope, the amount of slabs scales linearly with the internal area requirements. So, and also, yeah, we can reduce the envelope height if we reduce the of these slabs. So, of course, they provide structural, acoustic, and fire-resistant capabilities for the building, and may also embed piping and other installations. But there is usually a bit room, at least a bit of room to reduce the thickness. And some good practices include using these innovative technologies, for example, delta beam, bubble deck, and hollow core slabs in concrete construction. So, of course, do bear in mind that some types of slab systems also, and the care should be paid to overall design and choice of the floor slabs used. So, but then again, yeah, so it should be noted that it also, having shorter grid spans for columns, for example, makes it possible to use these lighter and less steel and cement intensive slabs. Yeah, and in our baseline building, this results in a potential carbon saving of 6%. Then commandment 7, so you should not build separate parking structures, and preferably apply parking policies to shift the demand if your zoning law allows it. So in particular, underground parking spots and places in parking towers should be avoided if possible. But if you have to have these parking spaces below the building, you should consider maybe raising the building so that the building stands on pillars. And this will save a substantial amount of materials from these walls that are not needed anymore. So here's an example. So the initial concept was to have two basements for car parking here, but removing the retaining walls and having the customer agree to one parking floor only, we got a really high reduction in the building impacts. So this was about almost 5% potential reduction in carbon. As commandment 8, we have use movable or refurbishable wall elements, so designed for adaptability. And this is to solve space redistribution issues. So as the floor plan configurations may often change, for example, in offices is quite common, it's a good practice to use these reusable and possibly movable internal walls to the extent that they work for the building function. So similarly, the electrification that tracks seating arrangements in office buildings. And this design for adaptability means that in the future, if I need to do refurbishment, it should be as easy as possible. And yeah, other methods are, for example, applying this construction practices that make it possible to remove the elements intact. So this is called design for disassembly. And in our reference building or baseline building, we got a 4% potential carbon saving by using these movable or refurbishable elements. And then as 9, avoid elements with limited value. So this means flooring, ceiling of facades mainly. but also, of course, other elements. So if your material provides only an aesthetic function, maybe consider omitting it. If your internal ceilings are, for example, not providing acoustic or fire protection, the entire element could maybe be removed. And this would also allow better maintenance, access to installations and cabling. So no need to take anything apart to reach them. And the same consideration applies to flooring. So a simple polished concrete floor could be a good option for some types of spaces. Of course, not all, but this is something to keep in mind. The potential carbon savings here were 4%. So here we considered if the building is cladded with an aesthetic steel facing, and also we took off the floors and used only this polished concrete. So these two choices. And also, yes, internal ceilings were also taken out. As commandment 10, choose long lead solutions for windows and roofing. So investing in durable materials means fewer replacements over time, which again means fewer carbon emissions, less waste generated, lower life cycle cost, and less tenant disruption. And of course, it's very cost effective because you are using materials for a longer time. So the replacement need is smaller, and thus you also save money for the client. So what is durable and suitable material for your market varies depending on the conditions, but the principle stays the same. And potential carbon savings here are 3%. So if we consider the original plan was to optimize nothing, so we began with about 6,000 tons of CO2 equivalent, and then decided to increase the service life to 60 years, and just by that we managed to save 2,000 tons of CO2 equivalent. And then we began implementing all these different changes, and when combined, the savings add up to 43%. So meaning that we save almost 2,000 tons or up to 4,000 tons from the initial stage of the plan. So this is something quite substantial. And of course, adding these 10 commandments, these are not all. So there are many more, of course. And these could include, for example, incorporating design for disassembly and other circular economy principles into the design, buying local materials whenever possible to reduce transport impacts, ensure structural material strengths are not generalized but optimized for different uses, by reducing waste through careful specification and buying with take-back agreements, and considering, of course, the material longevity. So even though something might seem better on paper, so it had small impacts, but if it means that it has to be replaced more often, then we get, again, these material manufacturing impacts that just multiply as many times as the material needs to be changed. And since the contest also entails this refurbishment project, so I would just suggest you check out these 10 ways to reduce embodied carbon emissions in refurbishment. So if you click that open, it shows you a similar kind of report, but just adapted to refurbishment. Yes. So let's apply these practices in an example project. So I will now move over to the OneClick LCA. First, I will quickly go through how to register and activate your account. So go to oneclicklca.com, log in, new user, register, fill in your information, and then once you get the email, you activate your username and then log in to the platform. And then what you have to do to activate your account is to create a building project. So by doing this, following these instructions. But now I will actually go here to show you once more. Let's check. Okay, so this is what the OneClick LCA page looks like. I hope that you've all managed to check it out. Go here, press login, and because I'm used it just now, I'm already in. Here is your main page with all the projects you created. So, or yes, this is for me. So all the projects I have created. And again, the public demos were here. So you can go and check these out if you want. So what we were supposed to be doing is to add a building again. Yeah, and just to make sure, OneClick LCA is it's a cloud-based software, so you don't have to download anything. So you just use it here on your browser. All right. First, maybe I'll zoom in a little bit so you see what I'm doing. So the license key was provided to you both in the presentation and in the academy. So you will find it in several places. I will find it here and then enter. Yes, it's our project. So now we will create a baseline. No, let's see. Sorry. Yes, name it as you wish. This is just for me to keep in order with all my different things. So the type, we could do also refurbishment or the office building or something like that. But since this is a general demo, I will go to the apartment building, which was the new build in your contest description, and continue with that. This is a bit bigger building. It has 10,000 square meters and 5 above ground floors. Click next. All right, so goal of this hypothetical design now is to show you how to apply some of these principles for reducing embodied carbon, as we just discussed. So what I will now do, I will choose my tools. So this was the plus A1. And we could choose other things as well, but we are now creating a baseline building to check some of the optimization things that we could maybe do. So this has chosen my tool, my scope. It's a new construction and everything is included. Click next, and now we will just use the default LCA parameters. So last time on Monday, I showed you how to review and adjust the LCA parameters. And there is also additional information here if you want. But now, because we've gone through it already, I will just use the default parameters. And then, so we have our design here. And we will start putting stuff in. So what I will do now is to take you through the recycled materials point. So we will add in some concrete. Let's see, something for the foundations, for example. Let's see what we have here. Okay, we could go for normal strength or something else. I will go and find C50 concrete, so ready-mix concrete with high strength. And we will choose a very generic one. So this one has very little recycled content in it. Let's take this one, for example, and we are going to make a foundation slab. So this is 2,000 square meters times, for example, 50 centimeters. And then we click save. And before we go check how it looks like, I am going to go to electricity consumption and just put 0 there because I want to show just the materials. Hope that it works. We are calculating for 50 years. And the building area is 10,000 square meters for gross floor area. Yes. Okay. Save. So now we only have that one concrete data point there. We are going to save these and go to the main page. So whenever you click this, you go to your project base. And it did not approve of my 0. So I'm just going to check with 1 if that works. Oh, yes, sorry. Of course, I need to select the electricity first. So that's it, why it was problematic. Let's see if it works now. Yes, okay, now it works. So we go to the project main page and see that we have here results. We only have this for one design, so I'm gonna add something else. So we create a copy for an optimized design. So I just go here and click copy. And this is copy of baseline, for example, added binders. Add it in. It's the copy, so it has the same materials. But if we go to building materials and we change it, so let's see, we got C50. High strength, and then we had that very generic material with no additional binders, but we are going to go with this that has, for example, 30% fly ash in the cement, so it's the same strength. This could be, I could use the replace function as well, but now I just do it like this, so it's another way of doing it, and then just remove the first one. And then we save. And once it's saved, we go back to the main page to check what it looks like. Okay, so it says that we have 25% reduction. So now if we go here with life cycle stages, we can see that we are already down this much. And then, I don't know, the engineer comes over and tells you that a lower grade of concrete is okay. So we might want to change it into a lower grade because higher grade means higher amount of these binders in it or higher amount of cement. We make a copy again, and this is copy of baseline with lower grade. Add it in. And then go into the design again to change the building materials. And now I'm going to do it the proper way. So go to change, replace. And now we have the quantity, but we want to have a lower grade. So for example, C25, which is something quite commonly used in Finland for foundations. So we are going to choose, for example, this ready-mix concrete, C2530, with, I don't know, 60, but I think we could go with, is there anything with fly ash, for example? 20% fly ash is there. 30% fly ash. So this is the same kind of percentage of additional binders in it. And we are going to save. And then again, check the front page, what it looks like. Go to life cycle stages, and again, we are reducing our impacts for that one material. So this is something that you can begin to think about your choices, optimize, and of course within the requirements and technical performance. So that's quite important to always think about. But yeah, this is how you could maybe start. And just as a small note, these kind of traditional binders such as GGBS and fly ash are actually running out because the need for them is so big. So new materials are being developed continuously. And if you wish to learn more, I would like to promote our next construction LCA bootcamp that is coming up in November, where we, among other topics, focus a little bit more deeply in materials and also have a very interesting guest lecturer coming from a company that uses carbon dioxide to replace cement in concrete. But promotions aside, this is how you could do this materials comparison, but now we will look how you can start optimizing an actual building. So we'll continue with this same project we've created. And there is a tab here called Carbon Designer 3D. So we are going to use this one in the asks for the tool. So we are using this plus A1 for levels. And then we are taken into Carbon Designer, which is another tool, but it's directly connected to the OneClick LCA main interface. So whatever you do here is you can like import and transfer everything you are doing. So here, yeah, you can compare create a design, or if you have made designs priorly, you can compare up to 4 different designs. Since we have nothing there, we are going to create a design. The first step is to enter this building information. So we are going to make a baseline building. And it asks to enter this reference building. So what you do here is you select the one that is closest to your region. I don't think that there is a Finnish one. No, because this Carbon Designer tool is like connected only to the Finnish regulatory methodology that uses only carbon as the impact or the indicator, global warming potential. So we need to choose a closest one. So that would be Swedish reference building. And this is quite important because it makes these assumptions and calculations based on the ways of constructing in different areas. So if you make a building that is located in Finland and you choose this Middle East and North Africa reference, for example, it will give you very strange results. But yeah, we chose Swedish because that is the closest one. It's given our cross floor area here already, and also the calculation period. So check those out. If it says something that it's not supposed to, just correct it. And then we go here. And then it asks for the building type. This is also quite important because the calculations and the building geometry and so on are related to the typical building in that area. So we go with the apartment building. So there's quite a few of these that you can choose from. And you can also do these mixed use buildings or this modeling for mixed use buildings. But for that, you would have to choose what is the most like what forms the biggest use. So if it's like an apartment building that has a bottom floor that has, for example, retail area, these kind of spaces, you would choose apartment building and then just adjust the material quantities later on. But yeah, now we go with the apartment building and click next. So then it wants to define the scope. For a new build, we are going to have all of these. It's also worthwhile to notice that this has also a lot of information. So if you click on these little arrows, it tells you what is included in all these different building parts. If you were doing a renovation or a refurbishment, you could choose to leave out some of these. So for example, foundations and ground slab might be there already, maybe also the enclosure, and just change what you want. but now we are doing this new build, so everything is included. And here it wants to specify the number of above ground floors. So we did this already, but if you haven't done this before, you can do it here. And also the number of underground floors. So here we have one unheated floor. No, sorry. Yes, unheated. And then it wants to define the structural frame and foundation options for your building. So you need to define the structural frame because this affects the density of the column grid and the quantity calculation for the different structural elements. Yeah, so I am choosing this one. This is a rather common frame type also in Finland, so precast column beam frame. Other options would be cast in situ with different these kind of column spacings, steel frame, concrete load-bearing walls, CLT load-bearing walls, and then this glulam column beam frame. Yeah, and then piling length for visualization, so you can add piles. This is not accounted for in the calculation, so it's for visualization as it says. And then you can also select any of the following elements to add to the foundation. So this kind of second piling wall or soil stabilization. And if you want to know more, you can also see from here, from these little arrows. But now we've defined the scope, so we click next. And it calculates the geometry for us. So the Carbon Designer buildings are these kind of shoe boxes. So they are always rectangular. But yeah, so if you have a building with a more complex shape, what you would do is you would create this baseline building using this kind of shape, and then you can always, like, for example, calculate the, for example, if you had different sized floors, for example, you could calculate the added or deducted materials and then just define this later. But here you can get this quick and easy first assessment, basically. And in an early stage, you might not even know what shape your building is going to be or going to look like in the end. So this is something that is very, very useful to do in the early stage. So yeah, so this is our building. It gives us the different dimensions. You can always click again here to see what is included and also how it's calculated if you're interested. But we are quite happy with this. So I'll click next, and then it defines the building structures as well. So here you can also edit. So the foundations, for example, if it needs to be smaller, or I don't know, ground slab needs to be a different size, or you are going to decide that you want less walls, for example. So for example, these internal walls may be something that you would like to alter. It also adds us these like default services. So these are calculated for our cross floor area. So this like 10,000 square meters of internal cross floor area. And once this is done, did I have something to say about this? So yeah, these dimensions probably should not be changed if you are in this early stage and don't yet know the final dimensions. If you choose to change some of the geometry values, the other values update accordingly. So yeah, so this is, if you make changes here, I believe, yeah, you need to recalculate areas. But if you make changes here, you don't need to recalculate areas. So yeah, but it tells you what to do. So it's quite safe to make these changes, just if you are interested. Okay. Oh, yes, sorry. The templates you don't need to worry about because I don't think that this license allows any templates or tool. So now we submit and take some time to calculate. Yep. Okay, so now it's calculate our design. So what it does, it gives us carbon footprint by element. So here it has everything, and you can hover over them and see what the exact amount of CO2 equivalent is in within these elements. And it's also an easy way to see what is the biggest emitter basically. So here you can see the highest column is the floor slabs, which is, as we discussed, usually the most carbon intensive part of the building. And you can also choose here to see them in a different way. So this is by material, by classification, the total number. The total probably doesn't say anything now, but if we make these comparative designs, we can reduce it. And then it also shows us the 3D view. And here we can also activate carbon view. So this is something that shows us in color where like the highest carbon impacts come from. So as we said, it's the horizontal structure, so the ground floor, or the floor slabs here. Then if we scroll down, you can see the building elements and materials. So these are all the elements in our building. So it's also divided by these different building parts. So we can click this open and also go from here. Here it gives us everything. So what is the building part, what is the data point used for it, and also what is the area, how much of the area does it form. So this is a way where, or a part where you can start doing these like mixed alternatives if you want. You can change these percentages. Also, it gives the total number of kilos of CO2 equivalent, so and how much it makes from the total. You can add comments or you can edit. So if you go to this show unused resources, it gives you a long list of different data points you can use. And these are usually interchangeable, so they correspond to each other. You can press the question mark to get more information on the data point. Let's go a bit back now. Yes, and then hide unused resource, too many to look at. So what I was thinking here is compare. So we are going to make another version of this and start changing some of the materials. So what we can do here, for example, there's quite a lot of different places where you can do this, but this is one, so you can copy. This will create an identical copy, so we are going to make improved design copy, and it should, yeah, so it appeared right here. So next to it, it's at the moment 0% above baseline because it's the same design. So what we now need to do is to visit the baseline, click it close, and then open the improved design and all elements. So it will show everything. So what we can, for example, start changing is, for example, what was the biggest one was the floors. So maybe we could change the floors if I can find them somewhere. Finishes, maybe the easiest way is to go here and just choose structure, floor slabs. Okay, so now I can see the floor slabs that have been used. I can edit them. Get here some unused resources. I would like to put some CLT. So we are going to have CLT slab floor assembly, including mineral wool insulation. And what you can do is you can change the area or you can change the share. And usually editing the share is the easiest part. So once I type in, it starts calculating. And once it has been calculating, it brings it up here. So now, of course, we have 200%. So you need to put this hollow core slab assembly as 0 and then click, and then it will again calculate. So now we have changed it into CLT. So 100% is CLT, and we can finish editing. And if we go up, we can see our improved design has 419 tons of CO2 equivalent, while the baseline had 669 tons. So if we activate carbon view, we can see that the highest impact still comes from the horizontal structures, but the overall impact has decreased. We are 6% below baseline at the moment. So other things we could do, we can just keep going through here. Well, services is something that you probably cannot optimize too much, at least in the early stage. So the further you go, of course, you can choose the products that you will use. But if you are using these generic data points, there's not much that you can do about this. But we can go, for example, to internal walls. Structures. Not here. Sorry. Yes, of course, internal walls. So we have a steel stud internal wall assembly with wooden interior doors. And here it's important that you keep the share as it is, or make sure that it stays at 100. So we can just change the steel stud wall assembly into wooden stud internal wall assembly, for example. Including mineral wool. Well, let's do this one, for example. So it's 100 millimeters, and we will choose this one. So we want 83% of this. We click. And again, it will calculate too much. So we need to remove this original one. Mm. Yeah. And there we go. So if I think we need to finish editing. I was too quick, or maybe not. Yes, so here, finish editing. And then if we go here again, we see that our internal walls have smaller impacts. We are already 9% below baseline. So this is something quite easy you can do to begin optimizing these designs. And like said, you can compare up to 4 of these different ones, and you can import whichever design you want to the main OneClick LCA interface. So, well, one thing more is that you can also, yeah, I think I mentioned these mixed frame options. So you can just do it by alternating the share here. And yeah, so I think that we want this particular improved design to start working on closer. So I can click here, and we can, well, there's several options. We can set this as baseline to compare to, or we can save it to a project. So this is exactly what we are going to do. So we save design to project. This is a bit similar to the import process. So it asks if we want to, what we want to do with the existing data. So there's a couple of designs that we use to make those concrete comparisons, but here I'm going to create a new design. Yeah, and of course, if you click here on the convert another, and you save, it allows you to bring also the other designs, or whichever design you want in this same page into the OneClick LCA interface. So if I now click save, sorry, my internet connection has been a bit slow today. So we'll see if we can actually do something with this. Yes, design has been successfully converted. And where did it go? Is it this one? Yes, okay, so it's this one, improved design. It doesn't have the energy consumption yet, and it doesn't have the building area set into the software. So what else? Yeah, so now you can just go in here and start working on the actual design. So it has all the materials that we just put in there, or the carbon designer actually put in there. So this is what's there. These are mostly, I see, constructions. So, but anyway, you can start working on this as you want. So like I said, alter the materials, or you can check these reused material parts. If you want to change these generic data points, you can use the, for example, the replace function, find additional materials and so on. And that's it basically. And then you just click on these different parts here to start putting in your inputs. So for example, electricity statistic Finland, we are going to put 0 because we want to have an embodied carbon assessment here. And then calculation period was set already in the carbon designer interface. I would check it if my computer was any faster. All right, yes, it's 50 years building area. So here you have to set that again. So you need this gross internal floor area, and that was 10,000 square meters. So then we click save. Yes. And again, if we go to the main page, we can do our comparison. So of course, now our 3 previous designs only had that concrete, but now we have the entire building. So if you do this for several designs, you can also do this comparison here, for example, by the life cycle stage. And of course, these are downloadable. You can do the comparison by element, also compare the elements. Of course, here it doesn't make much sense because we only have one building here. But yeah, you can do all sorts of things here. So this is quite a good feature. Yeah, so what I would probably want to tell you a little bit about the use cases. So what you can use the Carbon Designer 3D for? Well, it allows for this, as we saw, this quick baseline building creation with minimal knowledge about the project. Additionally, you can use this to define these reference values for emissions in the early stage. So your actual design, for example, it should not exceed X amount of carbon dioxide equivalent. So you can set it here by making a baseline. And yeah, the calculations are typical for building type and region. So fairly reliable, I would say. And yes, so you can also do comparisons between new build and renovation options with regards to the environmental impacts. So you can create a decent estimate for existing buildings in such cases where you have, for example, no detailed drawings or material quantities. And yeah, when saving the design to your project, you can then decide which parts are not the part of the actual calculation. So you can, like I told, check the reused box. So for the materials that are reused and also define those materials that are newly added. And another use case could be to use this as a complementary source for material data that is not available in your models. So you might, example, get structural material data and quantities from BIM models, and then use the Carbon Designer 3D to estimate the quantities for these services. So yeah, but that was it about Carbon Designer for now. So now we go back to our presentation. So we are here. No, we are not here. We are actually here. Sorry, I seem to have skipped a few slides here, but we covered everything. Don't worry. So we can then continue to optimizing the baseline results. So we already showed you how to do the comparisons in the project main page. What you could also do is use this do this hotspot analysis with, for example, this bubble chart, like I showed on the Monday session. So this is to easily identify which what changes can bring the biggest savings. You can use tree maps or you can use these bars. So for example, here is a pretty good representation of the B4 impact, so the replacements. So here you could make assumptions based on the material properties. So for example, internal floor finishes is not a very big contributor to the overall impacts. But then when you add the 2 or 3 or even 4 times of floor changing, uh, like you have to replace the worn out floor several times during the lifetime. So it just multiplies the impacts. And same here for internal ceiling finishes, for example. You can also do hotspot analysis in Revit, for example. So as I offered before, we offer a Revit plugin that allows you to easily move between these two softwares and bring material information to OneClick LCA for analysis of these environmental impacts. So unfortunately, I do not have the time to go through this in detail, but I again recommend you to check out our other trainings, like for example, the upcoming bootcamp that has a session dedicated to this. But there's also a link here. So if you are interested in using Revit with OneClick LCA, you can click here and it will take you to the help center that has, like I've mentioned, all the answers you might be missing. So here we have a plugin overview and also some important stuff uh, that you need to maybe know before you start using it. Yeah, so finding better products is something that we are going to check next. So you can also use easily do this in OneClick LCA. So you can define, for example, the benchmark based on your material on the or the market benchmark, and yeah, then you can find better products, for example, for regions, and then compare. And now I think I will show you how to do this in detail. So let's see. So for those who were attending on Monday, there was a compare option in the software that we didn't really go through. I was just saying that it is there and you can use it. So for example, we could go to the Monday sections design project that I created. So that will be this one. And we can see what we can do with this. So we go here and we go to results. All right, so for example, here we have the compare data option. So if we click that, I actually have added some concrete as a test, but I am going to show you how to do this. So we could go to edit data and let's just remove these two and add them again so you may see. So we, for example, want to use finish concrete. So where can I find? Oh, well, yeah, that doesn't matter. So we are using finish things, and we want concrete, for example, C30, oops, 37. Ready mix concrete for external walls, sounds good. And we want to have a specific data. All right, so actually I found this ready mix concrete for, where did it go? Save. Okay, this is odd. Where did it go? Sorry, I am experiencing technical difficulties. Okay, there it is. Yeah, so this is a ready mix concrete, quite normal, but it's made by Rudus in Roihupelto. So this is about 10 kilometers from Viikki or even closer. So it's a very local material. So we are going to compare it with another manufacturer specific concrete. Let's see. Okay, sorry. I think this was actually the only manufacturer specific concrete we had in Finland. So we are going to remove the country filter. And if you remember, choosing from other countries is also okay if you don't have a regional supplier, because we have that localization method going on. So it kind of adjusts the impacts to your chosen location. Okay, so yeah, we had one local manufacturer in Finland, but we are, for example, going to choose this Swedish data point, and we are going to use 1,000 square meters of it. And you can adjust different things. And because we know actually that Roihupelto is right next to Viikki, we are going to use 10 kilometers as the transport distance. And then we save. And then once it's done saving, you can compare the data. So it will bring you to this comparison graph. And as we are very close to our location, the A4 or the transport impacts are very small, but also our chosen product has much smaller these material impacts as well. So this is something that you could do to start comparing the data. And you can also, once you've chosen what you want, you can also import it to your design. And these parts these are related to the LCC parameters, so life cycle cost. But this is something that you don't need to add there if you don't want to. Then let's continue with this one. So a few words about interpreting the results and other aspects as well. So as we know, we've now gone through the main page over and over again. So if you go to the design, then return to project main page, you can quickly quickly get this overview on how the different designs compare with each other. And in the results page, you can check the designs in more detail. So for this for each different design, you have the results there in detail. So about the main page, so we have the embodied carbon benchmarks here. So these are related to this Carbon Heroes benchmarking program that actually gathers data from OneClick LCA. So whenever a design is made at OneClick LCA, we have data from it. And these are like anonymized and regionalized, like for each building type, and for that building type and that region, it will give you this embodied carbon benchmark, like so rating basically your design against others in that region for that building type. And then we have the embodied carbon by life cycle stage. So as it's embodied, there is no energy in it. So it's only the materials, and like where the embodied carbon inputs come from. And also by structure. So here you can easily see what is the biggest emitter, what has the biggest environmental impacts in your design. The main page, design phase results, give you these these results. So the unit depends on the chosen calculation tool. So for example, in levels, we have the total kilos of CO2 equivalent for that building. And for the building circularity tool, we have percentages of circularity. And the totals are shown per design option, and these values can depend on can differ depending on the scope of the tool. And results populate only when the mandatory data is input. So remember to put in the energy and the floor area and the calculation period. The graphs can be used to compare and allow sorting based on different settings, and the classifications and impact categories can be picked, and elements can be left out as well. The results page, so here you can just, it just shows you how you can view the results and input data. And results page, here you can compare the designs, but it requires, of course, 2 designs with data and the same calculation tool. The results page gives you the option to download Excel results or Word reports. So you can get all this data also to your own file, and then you can choose what to do with it. So you can draw different kinds of graphs if you want, or analyze it a bit more deeper if necessary. And in the results page, you can also analyze details per building element in percentages. And yeah, and then we also had the completeness and plausibility checker, which we checked out on Monday. So if you weren't attending, you can check it out from there. So what it means and what it does. Also, we got the most contributing materials. So this was also, we quickly went through on Monday. And on the results page, you finally get this variety of different graphs that you can check out and also download as images, or you can also download the data behind it to recreate the graphs as you wish. Yeah, and then we get a comprehensive list of all used data sources. And I could maybe show this to you as well. So if we go to the main page, actually, I will show what the demo looks like. So here we have EU full building life cycle carbon study. So this is only the embodied impacts of this office building. It's made according to EN 15978, which is also the tool that the levels is based on. The standard that the levels is based on. Yeah, so if we check out the results here, so you can also go and check out the different like how the material is input and so on. We are going to check the results. And here, if you remember from Monday or not, but here you can see the total of CO2 equivalents for the building, total carbon dioxide equivalent for this scope. And this is per square meter per year, so 13 kilos. And this is the social cost of carbon as well. So if you make life cycle cost calculations, you can maybe extract some information from this, but I don't frankly know much about it. But yeah, it evaluates basically the emissions based on this carbon cost. Agreed. Carbon Heroes benchmark. So this building rates here as against all building types in Ireland. So this is where the project was localized in. And then here you can always get more information from the question marks, and you can click these open and see different these stages divided into different parts, and from the details you can click open and see the construction materials by this building part, and then click this open, and you can see the most contributing materials and so on. You can print and alter this, like modify this appearance and so on. And from more actions, you can get these OneClick LCA reports as Word, or you can get these like yeah, in different ways. And also you can export the used EPDs if you want. But now I think this is pretty clear, at least. Oh, there is actually a question. Let's see. So regarding the structural part of the building, what materials do you recommend we use in the structure? We have investigated a lot, and wood and concrete are the ones that they use most in Finland, but we want to see more options, and also if this is real. So for Finnish buildings, it is concrete. Yeah, so that is the major, like the most used material for new buildings as well. So like I said, when we were making this carbon designer, like putting in the definitions, precast concrete, these kind of ready-made elements are used quite a lot. Sometimes also cast-in-place concrete, but this is something that you of course need to define yourself. But for example, I've lived in Viikki, close to this area that you're designing in for several years, and I know that for that kind of it's very flat, very even. You probably don't need to use precast concrete, but you can use other kinds of options. A timber frame is, of course, I'm a big fan of it. So timber is used quite a lot in Finland, and there are also these kind of like incentives to increase the use. And yeah, I think that that is something, a very good option for you to consider. Yeah, but steel frame, it's not that used in Finland, but then again, that's something that you might need to consider if you want to have these kind of like a bit more different options, or if you want to go with like business as usual and so on. And also like a mixed frame is also a very good option. So it's about like, it's not just about the impacts, but also about cost efficiency and things like that. So there are several options for you to discuss and think about. And also like with using our software, it's super easy to make these kind of comparisons. So just go for it and see what works best. Yeah, but then I did have, yeah. So that was it about the software part, and I don't really know much more to say. So we can continue the homework and question and answer. So homework is not actually homework, but it's like a self-assignment that complements your knowledge on the topic, and will also help you begin when you are making these actual calculations for your contest entries. So these are not going to be checked by anyone, but are just for your own good, basically. So for your self-study assignment, I'm urging you to use Carbon Designer 3D and create a baseline representing a typical building in Finland. So I would suggest, because we only have 4 levels, the Swedish building basically as a reference building. So I would suggest that you go check a little bit of how the Swedish buildings, for example, differ from Finnish buildings. It's not much, but there might be some country differences there. Do some research on what would be a typical building. So like I said, what kind of frame would it have? Is it like a precast or a cast in situ, or is it a wooden frame, and so on? And then I would just urge you to use Carbon Designer, make a copy of the baseline design, try how the carbon emissions can be reduced, and identify the building parts causing most impacts and so on. So just like continue what we just discussed, but do it on your own and try everything, basically what you can. Also transfer the designs into OneClick LCA, keep applying changes to further reduce these carbon emissions. And also look into alternative materials and products. So how does, for example, local procurement affect the overall impacts? And how does design for this disassembly, this reuse end of life scenario affect the results? So these are the kind of questions that you will be having to answer during the contest. So very important to get into grips with them. And yeah, so check what is the biggest saving you can achieve compared to the baseline. And of course, just to remind you, this biggest saving is, it might not be what you're looking for. So a biggest saving might be achieved for this shoebox made out of, I don't know, wood, but you might not want it. So how is what you want basically optimized using these different methods of optimization? Yeah, and then just as a reminder, go to the community. It's made for you. It's a space, safe space where you can just like, ask questions and respond to others' questions and connect and I don't know, engage in conversation. And as a reminder, I will be checking it so every now and then. So if you have something specific related to software, write it there. And then, so now if you have some questions, please, I'm here. I will just wait for a moment to see if you have anything. And if not, then we can stop this session. So I'm just checking the participants. Yep, no questions. Anything coming up? Probably not. So if there is nothing left unclear, I would just like to thank you for attending. Hope you all the best and good luck in the contest. And also that I hope to see you in the future on some of our other training courses. So I will now stop recording and yeah, have a nice evening. Thank you very much.